Hey, Algebra 2, we're going to jump right into Chapter 3 now, and the entire chapter of Chapter 3 is all talking about quadratic functions. In Chapter 2, we kind of talked about like different types of functions, like absolute value functions looked like a v, linear functions are lines, those type of things. Quadratic functions will all look like parabolas, so they'll either be a smiley face or a frowny face, depending on what type of parabola you're talking about, okay? And so in section 3.1, they focus on graphing quadratic functions. And so there's a couple different ways to graph them. The first thing that they're going to have us do is making a table in example 1. I kind of talked to you last chapter about how, if you can remember the shortcuts and stuff, of like how things are shifted or stretched or compressed, that you wouldn't have to create a table. But when you have stuff that's really super ugly, like this function is to start with, it's probably just easier to make a table rather than to try to dissect that and figure out what all those numbers are doing and how it's shifted and that type of thing. So this case, it is just easier just to make a table of values and graph your parabola. Let's go back up here. Every quadratic function that you will see in this chapter is going to look like standard form, which is ax squared plus bx plus c. So all your quadratic functions are going to have an x squared in it, an x, and then just a number. The number that's in front of the x squared, we call that a. The number in front of the x is called b. And then the number that doesn't have an x attached to it, that we usually call that c. Okay, but all of these are going to look like parabolas. So 3x squared minus 12x plus 6. They don't ask for a, b, and c, but I'm going to get you kind of trained to look for a, b, and c. The a value is going to be the number in front of the x squared, so that is 3. B is 12, but if there's a negative in front of that, the negative is going to go with the 12, and then C would be 6, okay? So they didn't ask for that on this problem, but I'm just going to kind of get you used to picking that apart and knowing the 3 different parts of the quadratic function, okay? They want us to make a table of values, and they've designated that they want us to plug in the numbers 0, 1, 2, 3, 4. And so we're going to plug them into this function. So the first thing that we're going to do is plug 0 in. You can use this little slot to figure out or to write out what that's going to look like. But 3 times 0 squared is just going to be 0. 12 times 0 is just going to be 0. So the f of x or the y coordinate is going to be 6. And then over in this spot, they want you just to combine those. So I have the point 0, 6. And we're going to plot that on our coordinate right here, 0, 6. Okay, same thing again. We're going to plug in our point 1. So 3 times 1 squared minus 12 times 1 plus 6. 1 squared is 1 times 3 is just 3. So I have 3 minus 12 times 1 is 12 plus 6. 3 minus 12 plus 6. That's going to be like negative 3, I think. So that gives me the point 1, negative 3. And I'm going to plot that point over here. Oh boy, 1, negative 3. That's a long ways away. All right, next one, we're going to plug in 2. 3 times 2 squared minus 12 times 2 plus 6. 2 squared is 4. 4 times 3 is 12. Minus, 12 times 2 is 24 plus 6. 12 minus 24 is negative 12 plus 6 is negative 6. Let me add that again in my head. Negative 12 plus 6. Yep, negative 6. So I have the point 2, negative 6. And we're going to plot him over here, 2, negative 6. Okay, 2 more. We've got 3 times 3 squared minus 12 times 3 plus 6. 3 squared is 9. 9 times 3 is 27. Holy cow. Minus 12 times 3 is 36 plus 6. Holy cow, 27 minus 36 is negative 9, I believe. Plus 6 is going to be negative 3. Yes, negative 3. Okay, so I have the point 3, negative 3. 3, negative 3. And then we can probably kind of guess what the last point is. We started at 6, we went to -3, -6, back to -3. I'm guessing this point is going to have a value of 6. Okay, so it's probably going to be the point 4, 6. Let's check and see. Okay, so going back, 3 times 4 squared minus 12 times 4 plus 6. 4 squared is 16. 16 times 3 is 48 minus 12 times 4 is 48 plus 6. So 48 minus 48, that cancels out, and I do get 6 as my coordinate point. Okay, so 4, 6, and this is going to be a really skinny, long parabola, and there he is. Okay, now this special point right here is the lowest point on my graph, and they call this guy the vertex. And we will call him the vertex as well. If it's a parabola that's going to be a frowny face, you also have a vertex, and the vertex is the highest point in that case, okay? So either a low point or a high point, both of those points are going to be called the vertex, okay? So our vertex in this case is the point 2, -6, okay? That's what he is going to look like, okay? We're going to do a couple more. I'm going to separate this video into 2 sections, by the way. I forgot to tell you that. So we're going to do up to like C here, where we graph the information, and then we'll save the maximum and minimum value information for the next video, okay? We have what's called axis of symmetry, and we have what's called the vertex. The vertex we just kind of talked about is the low point or the high point, depending on whether you have a smiley face parabola or a frowny face parabola. And then we have the axis of symmetry, which is kind of like an imaginary line that goes through your vertex. It's kind of what splits your parabola into 2 equal sections, okay? And the beautiful thing about quadratic functions is that we don't necessarily have to graph a table or make a table of values in order to find the vertex of like this equation here, okay? It involves using kind of another formula that takes just a little bit of time, but we can take this original function and we can use the formula and don't necessarily have to do a table of values to find that, okay? So we're going to go through here. Okay, so we're going to start with this function here, and we're going to find the y-intercept like it asked for. We're going to find the axis of symmetry, and then we're going to find the x-coordinate of the vertex. We're going to find the vertex, okay? And so I'm going to find the vertex first, and then I'm going to find the axis of symmetry. Axis of symmetry, which I a lot of times will call the AOS to abbreviate. So we're going to do that. We're going to find the y-coordinate, the vertex, and then the axis of symmetry. It says find the x-coordinate of the vertex. We're going to find the entire vertex just because it makes it easier, okay? So to find the y-intercept, we've talked about this before. When you're finding the x-intercept, let me just write a little note off to the side over here. X-intercept, you plug 0 in for y. And to find the y-intercept, you plug 0 in for x, okay? So that's what I'm going to do here is I'm going to plug 0 in for x. So I have 0 squared plus 4 times 0 minus 3. And what you'll notice is that anything that is attached to the 0 is going to go away. So my y-intercept just literally ends up being that -3 value, okay? That will always be the case with every single function that I have. The y-intercept will always be that last value here. If we go back up to the one that we just did, if I cancel out these 2 pieces, the +6 was my y-intercept. That ended up being my y-intercept there, okay? So that's just kind of always the way that it will work, okay? So -3 y-intercept. To find the vertex, this is something that I want you to remember. We just said the y-intercept ends up being the c value, okay? Oh my goodness, kid. Okay, to find the vertex, I want you to remember negative b over 2a, negative b over 2a, negative b over 2a, negative b over 2a. Okay, that's what we're going to use to find the vertex. Okay, so just like we did up here, identifying the a, b, and c values, we're going to do the same thing here. So a, b, c, let's write what each one of those are using this form or this function here. Okay, so a is the number in front of the x squared. Since there's no number, we assume that it's 1. Okay, so I'm going to list that here. B is going to be this number here, so it's a 4. And C is this last number, which is a negative 3. Make sure that the negative goes with it. Okay, for the negative b over 2a, we don't need the c value, but it's good to kind of write that out just because. All right, so negative b is 4. Okay, negative 4 over 2 times a is 1. So this is negative 4 divided by 2, or just negative 2. Okay, now that will give me the x coordinate of the vertex. Okay, like up here, that gave me this part right here. Okay, just that value. Now I need to go and I need to find the y coordinate. So the way that I do that is I take this negative 2 and I can just plug it in for x into this equation up here. Okay, so I'm going to do that. I'm going to do negative 2 squared plus 4 times negative 2 and minus 3. Okay. What? You're all right. All right, negative 2 squared is 4. 4 times negative 2 is negative 8, and then minus 3. And that's going to give me, I think, negative 7. Okay, so there is my vertex, is negative 2, negative 7. Okay, now I'm going to graph this real quick. So I'm going to go on to the next page, and we're going to graph this really quick, and then we'll see, I'll show you how the axis of symmetry kind of fits into play. Okay, so graphing these two things, I have negative 3 is going to be my y-intercept. So I'm going to put a dot here on negative 3. And then I have my axis, or excuse me, my vertex is negative 2, negative 7. So negative 2 down to negative 7. There he is right there. There's my vertex, okay? Now, you can kind of probably already see what this parabola is going to look like. This is my vertex, which means that he is either my highest point or my lowest point. In this case, he's going to be my lowest point, and he's going to end up going up like this on this side. And what's going to happen is he's going to have to be the same on the other side as well. So here is kind of like that imaginary axis of symmetry there. And this guy is 2 units on either side of, or on the right side of that axis of symmetry. So my other point is going to be 2 units on the other side, okay? And the other side of the parabola is just going to go that way as well, okay? But they want us to talk about what that axis of symmetry looks like, okay? So this dotted line, the equation of that dotted line, it's a vertical line, and vertical lines always have the equation x equals something, okay? And x equals, where he's going through the x-axis, is at negative 2. So the axis of symmetry, the equation for my axis of symmetry, if I go up here, is x equals negative 2. And there's kind of a trend with the way that that works. X equals negative 2, that will always be the x-coordinate of the vertex, okay? Those two will kind of always go together. So that's really nice in the way that that works out, because as soon as you have the x-coordinate of the vertex, you know where your axis of symmetry is located, okay? All right, so they say make a table of values that includes the vertex. They've listed my vertex here as like my middle term, okay? They want us to do that so that we can have a couple points on either side of that negative 2. We've already plugged the negative 2 in, and we got that the y-coordinate was negative 7, so negative 2, negative 7. That's where he fits. But then they want us to plot some other points as well. So negative 6, if we plug him in, we would have negative 6 squared plus 4 times negative 6 minus 3. I'll zoom in here. Negative 6 squared is 36. 4 times negative 6 is negative 24. Minus 3, that would be, I think, positive 9. Let me check that. Yes, positive 9. So I would have the point negative 6 comma positive 9. That's that coordinate, okay? Negative 4, if I plug negative 4 in, negative 4 squared plus 4 times negative 4 minus 3. Okay. Negative 4 squared is going to be positive 16. 4 times negative 4 is negative 16. So those are just going to cancel each other out. And then I have negative 3. So negative 3 is the y coordinate for that. I have negative 4 comma negative 3. Okay. All right, a couple more. So we have 0. If I plug 0 in, we said 0 squared plus 4 times 0 minus 3. That'll just give me that negative 3 value. And then you can kind of see the trend from here. Okay. Okay. We were at 9, at negative 3, at negative 7, at negative 3, and the next one's probably going to be at 9 again, right? If it's a true quadratic function, it will make that little U shape, and he will go down and then back up again, okay? So that's kind of what this one was. Use the information to graph the function, which we kind of cheated. We did that already. Negative 6 was at positive 9, though. So let's go to negative 6. We're up here at positive 9. So he's going to continue to go up through there. And then, what was it? Positive 2 is at positive 9. Whoop. Sorry, I'm hoping I'm not making you too dizzy. Positive 2 is at positive 9. So if he continues on up, he will look like that. Okay? So axis of symmetry, vertex, let me label my vertex here. Vertex was at negative 2, negative 7. Axis of symmetry was at x equals negative 2. And there's the information for our quadratic function. Okay? In the next video, I'll continue on and we'll talk about maximum and minimum points. So we'll just have one example. So hopefully the next video is kind of short for you. But there's just kind of an introduction into quadratic functions. Remember, negative b over 2a. You're going to have to use that a lot this chapter. So negative b over 2a, negative b over 2a. Okay?